Alright, question 1B. This is still from practice exam 2, working off this Mancala problem. We are now moving on to the problem that asks us to write a method for this class. It's asking us to write the method to move seeds across the board. So if you look at the description, it says on each move a player takes all the seeds from one of her houses and sows them, moving along the board counterclockwise, placing one seed in each pit, including her houses, her own store, and the opponent's houses, but excluding the opponent's store. For example, and they give you this example where they say, okay, suppose you are sitting at this side of the table right here, and you are deciding which house you're going to pick, so maybe you pick this one right here. So if we look in this house, it has 1, 2, 3, 4, 5 seeds in it. Okay, so out to the side, I'm just going to kind of keep track of some information here. So the number of seeds that we have is 5. Okay, so maybe that's our count right now. So we take those seeds, put those in our hands. I'm going to represent that by just simply erasing what was in the house. So we started here, took all 5 seeds, and now we move counterclockwise, placing seeds in all the houses and store until we run out of seeds. So we had 5 in our hand. I want to drop 1 in here. Now my count is 4. Still got 4 in my hand. I drop 1 in here. Now I'm down to 3. Remember, every player has a store to their right that is their own store. So I want to drop this in here. Now I'm down to 2. Come over across to the opponent's houses. Put 1 there. Now I have 1 left. So my last seed is going to be dropped in there. Now I have no seeds left in my hand, so I'm now done. I've placed my seeds around the board, and if we look, it says if the move ends in the player's own store, so had I ended up here, then I would have gotten another turn. So it says write the method move int k that implements the move from the pit with index k. So if I'm looking at this, maybe this is player 1. So this will be store 1, obviously player 2 sitting on that side of the board, and this will be store 2. Okay, assuming I'm player 1. So what would my index have been here? Remember, it starts at 1. So 1, 2, 3, 4. Alright, so that means the k value, for me to make that move, I would have made the call move at position 4. So I would have taken those, moved them around until I ran out of seeds. And then if you notice, it says the method should return true if the move ended up in the player's own store. So did I end up at my store? And the answer was no. If you remember, I had 5 to begin with, so I dropped off 1 here at 5, 1 at position 6, 1 in my store at position 7, 1 at position 8, and 1 at position 9. That's where my move ended. Since I did not end up in my store, this should return false. Okay, that's the basic breakdown of what's going on. So we need to figure out how to implement this method for all possibilities and all possible moves, whether it's player 1, whether it's player 2. Okay? So let's start by writing the header for our method. Public boolean move takes in an integer value which they are calling k. Okay, remember that's the index, the position where I want to take in, where I want to start my turn. So that's the house I'm picking. So if you notice the precondition that is listed on your paper, it says the precondition k cannot equal store 1, so I can't choose to start by taking all the seeds out of my store, and k cannot equal store 2, which means if it's player 2's turn, they can't start there either. So what I need to do is simply find a way to let's think about what we kept track of. I kept track of how many seeds I had in my hand at any given time. I kept track of, it may be useful to keep track of where we are. We definitely actually probably want to keep track of that because we want to know where we end up and whether or not we end up at a store or not. So we want to keep track of how many seeds we have, where we are, and it will also be beneficial to know which player is starting the game. Okay, which player is starting this turn, because remember what it said. It said that you put seeds in all the houses, but if you get to your opponent's store, you don't put seeds there. Well, how are you going to know which store is yours and which is your opponent's if you don't know which player is playing? So we probably want to keep track of which player is making the move, and we can figure that out because each player, it says a player takes all the seeds from one of their own houses. So if we figure out like, oh, maybe it's from 1 to 6, then it must be player 1. If it's from position 8 up to position 13, then it must have been player 2's turn. Okay, so we can figure that as well. And then we're going to go through and just start moving along, putting these seeds, taking them all out of the current spot, and dropping them off at these other places. So if we think about that in the sense of what that looks like in the program, we have an array that represents how many seeds are in each spot. So we'll take basically set the position we start at to 0, and then just start going along and adding 1 to whatever was there each time we go through. And then once we run out of seeds, then we'll just stop where we are and decide, is that a store or is that an our store, and then return true or false. So let's jump right into this. We mentioned we want to know where we are. I want to use an integer to keep track of that because it's going to be an index, one of these numbers across the board. So anything from 0 to 13. And I'm going to call it position. We'll just use the letters POS. And I'll start us out at position K, all right, wherever we're actually making the move from. So for instance, if we were looking at the example from earlier, position would start out equal to 4, because that's where we began. Then I'm going to make a variable called count to represent how many seeds we have in our hand that we're kind of dropping off each time. And how many do we have? Well, if I know where I want to start, then I'm going to take all the seeds that were in that spot. Remember, the name of the array was board, and the position we are looking at is K. So that returns the number that is stored in that spot, so the number of seeds that were there. And then I'm also going to, so there's a couple ways we could do this, keep track of which player, whose turn it is, things like that. I'm just going to make an integer variable, and I want to call it player. I'll tell you what, I'll set it equal to 0 to start with. And then once I figure out is it player 1 or player 2, I'll change that number. So if it's player 1, let's think about this. Let's look at the diagram and think about it. The house numbers that are applicable there are 1 through 6. Okay? Now the precondition said that they couldn't pick 0 and they couldn't pick 7. So I'll know it's player 1's turn if they pick any of these houses from 1 through 6. So what I can say is, well, I know 0 doesn't work and I know 7 doesn't work. That must mean they're picking some value in between those. Or in essence, negative numbers aren't valid indexes. We don't really have to worry about checking that. So what I could do is simply say, all right, as long as they pick something smaller than 7, since 0 is a precondition, they're not going to pick 0, I'm just going to say if the K number they tell me is less than 7, and instead of saying 7 here, what I'm going to do is I'm going to call the index of that. Remember, that's where store 1 is. So as long as they pick a K value before store 1, that must mean it's player 1's turn. Okay? So I'm going to say, well, set player equal to 1. If not, if the K value is bigger than 7, or bigger than where store 1 is located, then that must mean it's player 2's turn. Okay? Again, since these just go with one line of code, we don't need the braces for these if-else statements. It automatically executes the next line. Alright, so that helps me figure out which player's turn it is. Alright, so now imagine this. We've taken the seeds, we've got them in our hand, that's stored as count. So as long as I still have seeds in my hand, I want to start moving along the board and placing those seeds across each spot. Okay, I could use a for loop here, or I think it may be easier to use a while loop because we don't really know how many we have just yet, how many places we need to go. And I think the structure of this will be a little bit nicer using a while loop. So what I can do is I can say as long as I still have seeds in my hand. So remember, count represents how many seeds we have in our hand. So as long as I have something in my hand, that means I have more than 0. As long as count is bigger than 0, what do I want to do? I want to go to the next spot in the array. So think about this. We're using POS to represent our position. So I want to go to the next spot. I'm going to say position plus plus. Moves position up 1. Right? Then, once I go to that next spot, I want to put a seed there. But we got to check one thing. Because imagine I am player 2 and I pick position 13, the last house. Okay, remember how that looked? So 13 would be the last house for position for player 2, and then they would go to the next position, which started back over at 0. So if position was 13, if that's the original position of where they took their seeds, if I go position plus plus, that's going to say go to position 14, but there is no 14. So to protect or to keep this from giving me an out of bounds error, I'm simply going to say if we get past 13, so if position is, and actually think about it this way, position 14 is where we go out of bounds, and that's the board size. So I'm going to say if we reach the board size, that means we've gone out of bounds. We need to start back over at position 0. Okay, so if we reach the end, start back over at 0. So that position is 0. Okay, so that's a sort of a precaution there to make sure that we're not going out of bounds. So now what I want to do is I want to say, all right, as long as I'm not in my opponent's store, I want to put a seed down. Well, how do I know if I'm in an opponent's store? There's two cases here, and I can just use one long if statement here to kind of figure this out. So if I'm player 1, so if player equals 1, remember the player just stores the number of the player, and I am on any position other than player 2's store. So how would we write that? Well, I could say if the position we're currently at is not player 2's store, we are not equal to store 2 index, then I want to put a seed down. Or if we are currently player 2, player 2 is the one that's making the play, and they are not at position store 1, so they're not at their opponent's store, then we want to put a seed down. So now let's write the code to actually drop off a seed. Okay. So we are going to say we want to basically take a seed out of our hand. Remember, count is representing how many seeds are in our hand. We're going to say count minus minus. And then we want to go to that position on the board. Remember, POS is representing our position. We want to add 1 to it. So basically I want to say take whatever's there and add 1 to it. I could use plus plus here, or I could say plus equals 1, just to show you different notation. That means set it equal to itself, but let's add 1 to it first. Alright, so that adds 1 to whatever is stored there. And we only want to actually put a seed down if we are not in our opponent's store, and that's what this conditional statement here checks. Make sure if we're player 1, we're not putting it in store 2. Make sure for player 2, we're not at store 1. If we are at any other house on the board or our own store, then we want to take a seed out of our hand and put it on the board. Okay? And we want to do that over and over and over again. Keep checking this. Make sure that we are not going out of bounds, and we are keep incrementing our position, make sure we're not out of bounds, and then make sure we are not at our opponent's store. And if all those conditions are met, then we want to take a seed and drop it down. We want to keep doing that until we run out of seeds in our hand. So when count finally reaches 0, that means we've run out of seeds in our hand. The POS is going to represent the last position where we just put the last seed. So then if you remember, the last condition we need to do is we need to see, all right, if I'm player 1, if I ended up at store 1, I want to return true, that it's actually I get another turn. Same thing, if I'm player 2 and I finish up at store 2, then I also want to get another turn. I want to return true. If neither of those conditions are true, though, then we want to return false. Our turn is over. So to check that out, I want to say if it's player 1's turn, player equals 1, and we ended up at player 1's store, what would that look like? All right, what are we keeping track of our position with? POS, if that equals store 1's index, or if we are player 2, whoops, yeah, erase that. So if player equals 2, and we ended up at store 2, either of those cases are true, and we want to return true. Okay, again, returning true indicates that we would get another turn. If not, I could say else here, or I could just realize that if this if statement is run, we're going to return something, we're going to leave. So if I get past this point, it must be the else condition. That must not have been true. So then I can just say return false.